Alright, so continuing from where we left off, this is the attribute, so I just created this highest y position, right? And let's name this as well. So attribute hypos, so I know where my attribute is being created. And so what I wanted to do was get my highest value over there, right? So the way that I'm going to do this, each time this value changes, is going to do an if statement. It's going to go and check if the value that was recorded is higher. And since the default starts at 0, it will compare it with 0 initially. So the initial comparison will be with 0, and then from there we'll start to compare with whatever the current value is. So what I need to do is, let's start typing an if statement. I want my $ty, yeah, come on, $ty. If that is bigger than whatever is my current highest x, my highest y position, but this little x is basically referring to the x of the vector. So you've got x, y, z of the vector. If this current value is higher than that, yeah, then I basically want to return $ty. So if it is higher, okay, return whatever that is. If it's not, then return $hypos x, right? So that's the expression, right? So then from there what I can do is I can rewind these particles and just in my spreadsheet have a look at what their highest values are. Yeah? I mean, at the moment all their highest values will be the same because there's no randomization in the force, but you can just easily add some randomization into the force. So let's bring up a spreadsheet, yeah? And I'm going to have a look at my newly created attribute, which is there, highest position x, y, and z, right? So I'm going to bring up my point numbers so I can have a better look at which point that I'm looking for. So say, for instance, yeah, let's have a look at point 0. Yeah? There, hasn't been affected yet, but is almost going to be affected. So this point 0, as I start stepping through, the values that I'm looking for, this is point 0, this is my highest position, x component, so the x position, x component over there, this will start to go up, yeah, and each time as it increments, so you can kind of start to see it's about to go up, so it starts going up, yeah, so you see it goes up, 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 it reaches sort of its highest position, and it's going down, and this highest position has now been stored, yeah, so very useful to get the highest position out of that. Okay, now what I want to do is in the second one, so in the second input for my vector value, what I want to put is I want to put again an if statement, but this time I want to query, or rather I want to return a value if it's still going up or if it's not going up anymore. So in my last value I can actually use that in combination with my interpolation, my linear interpolation, to know when actually this linear interpolation should be happening or when it should not be happening. So it's going to be very similar to this guy, so it's also going to be using this expression, yeah? I'm going to say also if it's bigger or equal, yeah, equal to the highest, so it was basically when it reaches the top point, then I want to return 0, yeah? So what this basically means is, and 1 if it's not, yeah? So this means that the default value is 0, which means I'm 0, I'm 0, I'm 0, I'm 0, I'm still going up, yeah? I'm still, returning 0, I'm still going up, or I'm down, yeah? Which is, I'm on the grid, I've never gone up. So I'm 0, I'm 0, I'm 0, once it gets to the top, yeah? This value will start to be, this will fail, yeah, this statement, and it will start to return 1. So basically, as soon as this turns into 1, yeah, and 1, 1, 1, 1, 1, when it starts going down, yeah, that's when the interpolation needs to happen. Yeah. So now what I'm getting is, okay, when is the interpolation happening, and I'm getting what is the value, what's the maximum value, right? And again, you can check this in your spreadsheet if you wish to, but I'm not going to do this again. Okay, now I'm going to take a little break, little sidestep, and talk a little bit about linear interpolation. So in order to do that, I made a little graph, yeah? And what I've got here is a typical linear interpolation. So the way to interpret this is we've got two values, a value 1 and a value 2, and value 1, or rather we need to interpolate between value 1 and value 2. So we need to go from value 1 to value 2, right, over a certain parameter. This certain parameter is, we're going to name it t, yeah, and it's a normalized parameter, which basically means it goes from 0 to 1, yeah, in between that range. Okay, so I'm going to bring up the formula. So this is generally the formula to calculate these kind of things. If you have any math expressions experience, this will be very familiar and very easy. Anyway, remember this, because this is very important. I mean, this is something that will happen, or if you do any kind of interpolation stuff, this will return. So I use this quite a lot, either for opacities of particles or lifespan manipulation, color manipulation. In this case, to manipulate height values. I mean, it returns quite a lot. Okay, so this is the general scenario. So in our scenario specifically, we know our values. Yeah, we know value 1. Well, that's going to be the maximum value, right? So this is going to be the maximum y position, and then over a certain parameter, which I don't know yet. I will need to query this. This is what I need to find out, this t value. But I know my first value and I know my second value. My first value is the highest y position. My second value is 0, is the lowest y position. So I'm going to bring up my formula. Okay, so again we start with the same thing. And like I said, we know the first one. We know value 1, which is the highest y position. We know the second one, which is 0. So it's going to go from highest y to 0. Okay, so we're going to start solving this little equation, and we're going to say, okay, we're going to solve this so we can find t. So fill in 0, 0, this falls away, and then start solving it further. Bring in the highest y position to the other side, and then finally we find out what t is. So t is equal to 1 minus $ty over the highest position. This is basically a ratio. That's the way you have to see it. This is a ratio of the current value over the maximum value. And this 1 minus inverts. So it's basically quite useful to as the component, the complement. Sorry. Okay, so we're going to be using this expression now to drive our linear interpolation inside of Houdini. I mean, I use the same values and the same attributes, so it's a bit clearer and a bit more applied. Okay, so back into Houdini. Okay, so I'm gonna close these things for a second. Right. So let's start typing our expression. So I know that my expression needs to be 1 minus, and then let's start typing $ty, so that's what we knew, over $high position, which one in this case? Okay, I need to use the x value, okay, and this will start to return a value. So let's have a look what this value is at the moment. So again, spreadsheet, bring up the spreadsheet, and I'm gonna rewind this and start playing this. And you can see my highest position in z immediately jumps to 1. The problem with that is that, I mean, at least for some of them, so let's let this run through and see, and then it starts changing again. And some of them are negative, so that's not very good either. And some of them are actually kind of doing what we want them to do. So as I start running this through, so let's just say, when are they doing what I want them to do? Is basically when this point, it's almost reaching its maximum value. It's just reaching its maximum value, and now it's going to start going from 0. Over there, it's going to do the interpolation. And it's going, as you can see, it's going up to 1. But there's some problems. In the sense that if I rewind this, all my values are 1 already. And that's basically the reason why I said, okay, I want to know when they are going to start going down. That's what this statement returns. So again, if I now look at my high y position, I'm going to see, okay, this is all 0, which means these are bad values, so to speak. I don't want to use them. And this has now become 1, so these are good values. So from this point on, if this is 1, start using these values. If this is not 1, so if this is 0, then I want to put this to 0. So on top of my linear interpolation over there, I'm going to put in an if statement. Yeah? So let's put in an if statement. So I'm going to say, okay, if, yeah, my other attribute is $HighPosition, yeah, the y component of this one, yeah. So if this is true, then return that. That's fine. If not, so if it's false, then I want it to return 0. So I'm just gonna clean this up a little bit, and let's have a look at what this returns now. Yeah. So now all my values are nicely zeroed out. It's going up. It's going up, 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 and then they're starting to go down again. Yeah? So at the moment these guys are 1, and you know the values are starting to go up. So that's what I need. Yeah? So there, and this is all fine. Yeah? There is one little problem that is occurring, and it doesn't show up straight away here, but it shows up later on in the exercise, and that's basically the collision. Yeah, it has to do with the collision. Is basically when the particles go, yeah, and they collide, they detect their collision, but sometimes they're slightly below the grid, so they kind of overshoot the grid. They know, oh, I've actually collided, so I need to correct my value, which basically means that some of these values go negative a little bit, and we don't want that. So in order to correct that, at the moment, obviously nothing is negative. So in order to correct that, one more thing to put around it is a clamp, so to make absolutely sure that this value is normalized. So I'm going to do is this return value, yeah, I want to make sure this is absolutely normalized, so I'm going to say a clamp expression again. So this is my value that's in the first field, then the minimum, then the maximum. So like this. Okay, so this is becoming, you know, slightly more complex expression, but still, you know, we understand what it does, so it's alright. Okay, so now we've got this one. Very useful to continue on now. From there on, I'm going to use this one to drive a rotation. Yeah. So there are currently no rotations going on. There are, however, velocity vectors. Like I suppose there are velocity being, you know, is inside of the particle system. If I rewind this, yeah. So there, attributes v. Yeah, v is for velocity, so that's the velocity attribute. And the problem with that attribute, and we'll show that later on, is that it goes straight up, and then as soon as the particle starts going down, the velocity vector flips upside down and flips down again. Now what this has for an effect is that basically when the boxes are copied onto the particles, the boxes start flipping, and it's something we don't want. So we're basically going to ignore the velocity in this case and create our own vector attributes and our own rotation and override the velocity and the up vector to, you know, disable that effect. But first let's add a rotation. So a rotation. So just a rotation. Yeah. And what I want to do is I want to break these channels. I don't need them. I'm gonna put in my own values. Yeah. So I'm going to say delete channels. Yeah. And this guy as well. Delete channels. Yeah. Come on. Delete channels. Yeah. So say that this is where we basically can start to control how much the particles need to rotate and which axis. So as a starting axis, let's just type in 1. And the angle I want them to rotate is basically 180 degrees. But at the moment, all of them are being rotated 180 degrees. What I'm going to do now is use that linear interpolation, the one that I've calculated there in my z component, the z component of my attribute, my highest position. So this one will go from 0 to 1. As it is at the top, it's going to be 0. As it is at the bottom, it's going to be 1. Yeah? So if I multiply this guy, so say $highest position, z, multiplied by 180, this means that instead of going from 0 to 1, it's going from 0 to 180. Yeah? This angle takes in degrees, so not radians, so no need to do times pi or something like that. Okay, the only thing that I might add at this point, if you wanted to, is a drag. It's not really necessary. It's just changing a little bit the way the system works, slowing it down a little bit. I mean, yeah, nothing too special. And I'm going to add a null, yeah, just for a clean workflow, which is just going to say out. So at the moment I've calculated pretty much all the attributes that I needed. I've got my my highest position, I've got my rotation going on, so over there my highest position, and it's around the x-axis. So later on we can start connecting these attributes into my master control node, and drive all of these, or make it into an asset, something like that. Okay. Now let's bring our copy back all the way at the top. There's our copy. Let's have a look at what's going on. Okay, so there's my grid. I'm gonna scale down the size of my box a little bit so it kind of fits it a bit better. Something like this is good. And let's play this. And as you can see, it seems to be working. My particles are nicely rotating, and they're doing their thing. But are they really? Because we can't really tell at the moment, because there is no no way of seeing if they're actually flipping or not. And they are flipping. So what I'm going to do is I'm going to add some groups to this and color the different faces based upon those groups. So first of all, let's call this group top, just for the top faces. And I'm going to say $OS. I'm going to have a look at my box. So let's home in on this box. I'm going to enable my primitive numbers so I can see my primitive numbers, and that's number 5, so I need to grab primitive number 5. So let's have a look at our group now. By primitives is fine, the color attributes by primitives, so that's fine. Okay, so what I need to do now is color this, add a color. Let's make it yellow, something like this, and let's put in the correct group. So the group that I need is the top group. Let's have a look. So now the top one is yellow. Okay, and just something small, if you press C over a node, you get this little color menu. So let's just make this one yellow, so I kind of know which color it's giving to the group. I'm going to copy this once and once more, so I know which one is the bottom and I know which one are the sides. So let's put in like that. Right, so group top, I'm going to change this to group bottom. Oops, I just renamed the wrong thing. This one, group bottom. Right, the pattern is going to be different, so let's press W to see which number is. So it's number 4 over there. Number 4. I mean, again, you could group, instead of group by pattern, group by expressions, put in an expression, make this all procedural, but it's a little bit overdoing it. Okay, well, at least for this kind of geometry it's a little bit overdoing it. Right, so I know that the bottom one is going to be red. So type in the bottom one. So let's have a look now. If I go back over there, so my primitives are selecting only that one. This one is selecting the bottom, and now I need to grab the sides. So the sides is 0, 1, 2, and 3. So let's just type those into the sides. So 0, 1, 2, and 3. You could just select them, transfer your selection. And let's name it sides. Okay. And I'm gonna give them a bright colors, green. Alright, so they're green. And again, press C, make them green. Let's have a look. Yeah, one thing to keep in mind with all of these actually is at the moment they're kind of being colored weird. That's just because their classes are not corresponding. So just for example, right, I've been grouping by primitives, which is fine. Over there I need to group by primitives as well. So all my classes of my colors need to be by primitive as well. So just change this all to primitive, all your classes to primitive, and let's have a look. And now this should be yeah, group top, it needs to be group sides as well. And there we go. So the top one is yellow, the sides are green, and the bottom one is red. Okay, so that's all good. These groups will later on become useful when applying textures, so that we can say like, okay, apply this texture to the top group, this texture to the bottom group, and yeah, go from there. Okay, I'm gonna zoom out a little bit and turn off my primitive numbers, and let's have a look. So if it plays now, you can see they're flipping, yeah, and they're flipping again afterwards. Yeah. So the problem that occurs is they're flipping on their side, so we're definitely gonna have to change their orientation. And the other problem that occurs is the velocity at the moment over there, see these are not affected, is 0. Their velocity there starts to happen, so as soon as that happens, their velocity vector is turned to 1, say positive in y. And then as soon as they're going down again, yeah, they're kinda flipping downwards as well. So we're going to start overwriting these vectors because we're going to be using our own, and later on if you wanted to, you can calculate your velocities with a trail operation afterwards, you know, like underneath there if you wanted to, for motion blur. Okay, so I'm gonna lay down a point sop, yeah, and under particle, yeah, you can go down and say, instead of keep velocity, I'm going to change this and say add velocity. I want to get rid of this, yeah, so I want to say, okay, this guy, let's delete his channels, delete the channels of this guy, yeah, and I always want him to be 1. I always want him to be pointing upwards, yeah. Okay, so that's useful, that's one thing. Now I need to change my orientation of these guys, so they're kinda correct. That has to do more with the way that the copy sop works. The copy sop is basically going to use the Z. Yeah, anything that is in Z is pointing forward, so in this case the side value is pointing forward. So I'm gonna have to rotate that around X, yeah. So in order to have the top one, the top yellow face, point upwards in Z, yeah, so I have to rotate this. So let's put a transform underneath there. Yeah, so a transform there. So you'll see it as I start doing this, as I start rotating this guy, you can kinda see if I make it visible. So if I say, okay, I want to see up, so now it's facing forward. You have to see this as the yellow face will start to go up in Z. That's the way the copy sop interprets it. So that's 90. Yeah. So if I look at this now, then you can see all my boxes now are nicely red at the top. Yeah. And then they start spinning and turning and doing their thing. Yeah. So that's good. Yeah. Yeah. So from there, what we can start doing is start thinking about textures, right? So start thinking about, okay, how am I going to apply these textures to this object, right? I'm going to say, okay, let's have a look. There's 400 primitives in the group and 400 primitives in the bottom. So I'm going to start projecting my textures, and it's going to be different for the top and different for the bottom. Okay. But first of all, let's see what we can do with these, you know, now that we've got this cool example, what we can do to manipulate the information that we have on the points. So just as an example, right, I'll just give this a name just so I can know what this does. This is like basically velocity override. Yeah, so the velocity is not being taken into account anymore. And I'm going to add another point. And this is really, you know, you're out of your particle system, yeah, and you can really start to use this information however you wish. So at this point you can say in $ty, say ×2, which will make the y information go twice as high without having to resimulate, because you're just manipulating information afterwards. And now those particles, you know, start to go, you know, a bit higher. But again, you know, if you think it's a bit boring that they're all, you know, going up at the same speed, one thing that we could do is go into our particle network, go into our force up, yeah, this is our upwards force, we're inside of pop's upwards force. Don't manipulate this, but start manipulating a bit this noise, yeah. So the amplitude, we only want to manipulate it in y, yeah, so the amplitude in y says something like, I don't know, 2, so not all of them will go, you know, up as much. Well, this will influence it a little bit, maybe something a bit bigger, something like 5. This will really start to kind of bring out a different shape. Again, this is a control you kind of want to give to the user to influence that frequency and all that. You can all export those controls. The cool thing is now that, you know, if we look at this and play it back, you know, they're not jumping all at the same height anymore. Yeah? They're a bit more random. Again, another cool thing is, what if we just say 0 times 0? Well, then they're not going to jump, but they are going to rotate, which is kind of cool, you know? So you get this billboard changing kind of effect, you know, it's like, yeah, quite a nice little effect that you can get. I mean, the other thing, this is really the next step, is you can apply this effect on a moving model, and you can base it on the UV position, you know, and then transfer it and transform the faces along the normal of the moving object. I mean, it's not dynamic at that point, but you know, but that's a bit too advanced for this example. So okay, let's continue on. So I'll just, I don't know, see over there you can also put in one more thing, is like say this exponential sort of expression. So if you kind of want to go over the frame rate, yeah, start saying, okay, what if I say, okay, times $FF, yeah? Something like that. This is playtime, so this is something that you can do in your own time and kind of have a look at it. So we want, say, a small value, or starting by a high value, because it's going to go up really fast. Yeah? So we're going to have to watch out a little bit what we do with it. So say, if we start saying, let's divide it, let's make it really small at first, yeah. But it should start to go up. Okay, it's a bit too small, so let's say, what if we make this exponential? So something like, let's put in exponential, like the, what is that little pow? We could use either the pow function or that little head, this guy. Yeah, so this will start to, see, give this kind of upwards motion as it goes out, just by making it exponential. Now see, this number is something I just, you know, came up with, and I just you know, did on the fly. If you want to change this, I mean, again, can influence this afterwards. I mean, it's a nice movement. Let's say maybe something like 3,000 instead, so they kind of go up a little bit higher on the sides. So something like this. Yeah? It's quite cool. Okay. From there, I'm going to save this again.